This short video shows you how to make sure Thermica is installed properly and running. When Thermica installs, it's usually installed, people install it at the C root level, although you can install it anywhere, and you can even copy this directory somewhere else and move it to some other directory or some other drive. There's nothing in the registry or anything else in the system folder of Windows that points to it, so you can move it wherever you want. The key thing is there's 3 environment variables that need to be set. Some people set them at the Windows system level when you set, where you set your environment variables, and some people prefer to use a batch program. And if I edit this batch program that we give you a sample file here, and there's only 4 executable lines, the rest are just comments. One of them is to set the environment variable for the MSC license variable, and here I have it set to a local license.dat file, but it could be set to a license server, as here you just comment this line with the REM and then uncomment the REM here and point to your license server. So that's one thing that needs to be set so Thermica knows where to find the license. The second thing is you need a home directory that says where the files are installed, and in this case just C:"Systema MSC 451. And then third thing you need is a working directory, so it's set Systema working directory, and I just put it to the root level. This is just whenever you open a file where Thermica is going to first look for that file. You can put it in some directory where you put your Thermica files or actually change it from time to time depending on what project you're working on. And then finally it launches Thermica using this path to the home to find the home directory, and it launches the executable, the Systema MSC Win executable. If you have your environment variables all set, you can just launch that executable. I usually just drag this, right click and drag it out, make a shortcut on your desktop, and sometimes change the icon to make it look a little prettier. But we don't automatically install an icon. So I prefer this method, the batch method, then you don't have to set the environment variables on your Windows system. Then you just run this and it will set those environment variables and it will launch Thermica. You can go under the MSC Thermica menu pick here and go about, and you'll see what license you're using and a little bit about what version it is. In this case where it points to acquired 1 license, and it gives you the name of the feature that it checked out. You can load a model and see if it's working right, and load a trajectory and kinematic and create a mission and then set up your processing and go through all those steps. But the fastest way to check it out is just load a sample model. If you come under the processing tab and load a sample model, and the one I would recommend because it runs fairly quickly is under workshops and training. It's called telescope training and it's Thermica only. And there's a process SYS-PRC file, and this process file here will includes generating nodes, conductors, radiation conductors, solar flux, planetary fluxes, a skeleton file which assembles all of that into a Cinda file, and then it runs Cinda. So this is kind of a run all, and that's why it's called run all. It runs every step required. And because the mission was pointing to tel1.sys.mis, it had to open that file, which is here. And this file, the mission file, points to the model file, meshing, trajectory, and kinematic file. So the mission file, when you open a mission file, it opens these other ones. So by just opening that process file, it actually opens your entire model. Your trajectory, here we can zoom in with the zoom button or right click and say fit trajectory. We can see our trajectory and animate it. We can look at our kinematic laws and how we, in this case, have 2 axes of rotation pointing the solar panels towards the sun, and that's set up for us. And then the mission shows the spacecraft in orbit, and we can animate that and see how the articulation, if it's working correctly. So now we'll go back to our process tab here, and I'm going to hit the run button and just say run, and and it will run all of those steps listed on that diagram. It first ran and computed the radiation exchange factors, the REFs. Now it's computing the planetary fluxes, which is the slowest of the steps. And you can see for the planetary fluxes in the albedo, it's doing both of those. It's showing what the solar constant is on the planet to get the albedo, and also the reflection, the albedo, which is a reflection of the solar flux off the atmosphere. And now it's going to calculate the solar fluxes, which happened fairly quickly. You see when it went into the eclipse here. And then it's calculating the conductors in the Cinda model. And then it's calculating the nodes for the Cinda model. And now it's running the skeleton file to assemble this all into a Cinda.sin file. And then it will launch Cinda and run very quickly. Cinda ran in just a few seconds. And then it comes back and it's all done. And now we could go back to our mission, and we could come under this little gears here, and we could load the results. We have to first go to the meshing because we look at results on our meshed model, which happens to just be a 1-by-1 mesh on all these shapes. So it looks just like the shapes. We don't actually see a detailed mesh because these were not meshed more finely. And then we have to make sure we click on the shape because we want to post-process on the geometry. And then under here we could pick something like absorbed solar flux. Let's see, absorbed solar flux here. And then we can see we have 1021 at the maximum of absorbed flux, and I can move the slider at different points in the orbit when you're in the eclipse, or you can see the sun back there when it's shining on the panels, and or you can do an animation and even hit this record button and record it into a MPEG-4 movie file. You can also go back to the model file and look at the model and look at either the model or the meshed model and materials that were used in the model. And when you look at the meshed model, you can also post-process results back here, but we're just not in orbit. And there's the planetary flux results, there's the albedo, there's mean results, which are orbit average results, and then the non-mean are the transient results, which change in time. And in the modeler tab, you don't see the animation of the articulating parts, and you don't see it in orbit around the Earth, where when you post-process on the mission tab, you'll see all of that. So this concludes the brief video showing how to make sure Thermica is set up correctly and running correctly.